Welcome back. In this video, we will talk about the assignment of R and S configuration to molecules. Configuration is actually a permanent geometry of a molecule that results from the spatial arrangement of atoms or groups around the central atom. For example, in this molecule, the two bold bonds as attached to carboxylic and methyl group lie in the plane of paper. The wedge bond as attached to chlorine is facing the viewer, while as the dotted bond as attached to fluorine is away from the viewer. This representation is known as the flying wedge or wedge dash representation, as it depicts the spatial arrangement of atoms or groups around that central carbon. So this is the configuration of a molecule. Now, this cannot be the only configuration possible. There can be other configurations also for the same molecule. As you see, in this case, chlorine is attached to the central carbon by wedge bond, while as the fluorine is attached to the central carbon by dotted bond. However, in the next, fluorine is attached by wedge bond, while as chlorine is attached by a dotted bond. So, as the two molecules differ in the spatial arrangement of those atoms or groups around that central carbon, so they have the different configuration, though they have the same set of atoms. Such molecules, which differ from each other in configuration, but possesses same set of atoms or groups, we call them stereoisomers. Now, how can we differentiate the two isomers? Cahn, Ingold, and Prelog gave a systematic nomenclature commonly known as the R and S system of nomenclature. The rules as governed by Cahn, Ingold, and Prelog system are: atoms directly bonded to chiral center are given priority based on atomic number. Atom with highest atomic number gets priority 1, while the atom with lowest atomic number gets priority 4. That is, as you know, bromine is having high atomic number, then chlorine, then fluorine, and the least atomic number is for hydrogen. So we can give the priority as 1 for bromine, 2 for chlorine, 3 for fluorine, and the least priority atom is hydrogen. After assigning priority, molecule is viewed in a way so that least priority atom is away from the viewer. Then once you move from 1 to 3, if it moves clockwise, then the molecule is R isomer, which comes from Latin rectus, meaning right. And if it moves anti-clockwise, then the molecule is S, which comes from Latin sinister, meaning left. In this particular molecule, as it moves clockwise, so the molecule is having R configuration. Point to be noted is that if the attached atom is same, then priority is given based on the next attached atoms. For example, in this molecule, chlorine gets the priority first because of having high atomic number. Then the carboxylic carbon gets the priority second because the next attached atom is oxygen. In the case of methyl, the next attached atom is hydrogen. So hydrogen is having low atomic number as compared to oxygen. So carboxylic carbon gets the priority second. Then obviously methyl carbon gets the priority third. And finally, the lowest priority atom is hydrogen. As you see, the lowest priority atom is away from the viewer. So once you move through 1, 2, 3, it moves clockwise. Therefore, the configuration is R. In the next example, chlorine gets the priority first. Ethyl gets the priority second because it's attached to one more carbon. Methyl gets the priority third. And finally, you have the lowest priority atom, hydrogen. And as hydrogen is away from the viewer, shown by dotted line, clearly, once you move through 1, 2, 3, it moves clockwise, so it's a R isomer. In the same way, in this molecule also, the lowest priority atom is hydrogen, which is away from the viewer, so it moves anti-clockwise. Therefore, the configuration in this case is S. Before moving further, we need to note one more point is, if we have a doubly bonded carbon, it is as if attached to two other carbons. A triply bonded carbon is as if attached to three other carbons. So while giving priority in this particular molecule, the chiral center is attached to carbons. Now alkenyl carbon gets priority 1 because it's as if attached to two other carbons. Then the ethyl carbon, then we have the methyl carbon, and finally the lowest priority group is hydrogen. As hydrogen is away from the viewer, clearly as we move from 1, 2 to 3, it moves anti-clockwise, so the configuration is S. Now the point is, we cannot always be having the lowest priority group away from the viewer. So it can be towards the viewer, it can be in the plane of the paper. That makes the assignment of configuration a bit difficult, as it needs a good degree of imagination. To avoid that, so it's better to convert the Vatch formula into a Fisher projection, because the assignment of R and S in Fisher projection is very easy. The conversion we talked about earlier in previous videos, the link has been placed in the description. Thus, in Fisher projection, if the least priority group is placed vertically, then the assignment is straightforward. Moving clockwise gives you R isomer, while moving anti-clockwise gives the S isomer. However, if the least priority group is placed horizontally, then the assignment is reverse. That is, moving clockwise gives S isomer, while moving anti-clockwise gives R isomer. As you see in this particular molecule, the least priority group is methyl, which is placed vertically, so the assignment is straightforward. Moving clockwise will obviously give the R isomer. Similarly, in the next example, once you move from 1 to 2 to that of 3, it moves anti-clockwise, but as the least priority group is placed horizontally, so it will not be S, it will be R. In the next case, you are again moving anti-clockwise, but the least priority group is placed horizontally, so this is again an R isomer. In the third case, moving through 1, 2, 3, it moves clockwise, so should have been R, but the least priority group is placed horizontally, so you have to reverse the configuration. It is not the R isomer, it is the S isomer. Now, if the molecule contains isotopes, then instead of atomic number, atomic mass is taken to assign priority. For example, in this case, fluorine gets the priority 1, and there are 3 different isotopes of hydrogen attached. So tritium gets the priority 2nd, then deuterium, then finally we have hydrogen. Now as you move 1, 2, 3, it moves anti-clockwise, should have been the R isomer, but the least priority group is placed horizontally, it will be R isomer. I hope you understand this. If you like my videos, please do not hesitate to subscribe and share. Thank you.